Good day everyone. Today's lecture is about chapter 5 in the textbook Title and Title, CL2 program, and chapter 5 is about functions. Now the question is, what is a function? Let's say for instance we have an algorithm, and this algorithm is called A, and we need to repeat this algorithm multiple times in our main program. Now, if this algorithm is only 3 lines long, this is not going to be too difficult to do. But let's say this algorithm is 15 lines. Then it becomes much more tedious to repeat, and errors may exist. So how can we make it simpler? Now, the programmers of the C programming language decided to create functions. Now, what a function is actually a block of code. And let's call this block of code A for the algorithm name. And we can take all this code and we can put it in that block. Now, in our main program, when we want to use that code, we don't have to repeat that code anymore. We can just go and call that block of code. And if you want to repeat it multiple times, we can just go and call it. So that's the basics of what a function is. When we want to go and call it, we just call it by its name. Further, let's look at the syntax of how a function is constructed. Now, the function is constructed out of a few parts. Let's look at the function from the beginning to the end. Let's say we have a function. I'm going to say void function 1 int A. This is going to be our function prototype. Okay, that's what we call function prototype. Function prototype. Okay, not going to write that out. So now you're asking me, what is this? I don't understand. So let's quickly break it down. First of all, this first part is called our return type. This next part is called the name of the function. And this part in brackets is called the parameters. Now, the return type will send information back to the main program. So let's say if this function is called and this function does certain calculations and it gets to an answer, the return type is the type that we will use to send information back to the main function or the main program. So sends info back to where the function was called. Okay, so our return type sends info back to where the function was called. Okay, so that's in most cases in our main program. The name of the function, it's quite obvious, is how you would call that function. If you call a person, you just don't say, person come here, you call that person by its names. Like, for instance, John, come to me. And then John will know he needs to come to you. And in the same way, when we call a function, we need to call it by its proper name. Please remember that uppercase and lowercase do apply. So you need to be very specific with your name and how you call that name. Okay. And then we get to our parameters. Now parameters is just the opposite of what the return type is. Now the parameters is to send information to the function. Okay, so the return type sends information from the function to where it was called, and the parameters is used to send information from where it was called to the function. So now that you understand the function prototype and each facet, let's quickly do a quick example. Let's say we have a program and we need to implement a function to calculate the square of a number. So let's quickly look at how we would construct our program and our function, and a function to calculate the square of a number. Okay, so let's start off. First of all, we always start with #include stdio.h. Okay, next up we will give our function prototype, and our function prototype is going to be int. Okay, so why int? When we create a function that will get the square or calculate the square of a number, what will that function send back to us? Let's quickly think about it. Let's say when we calculate the square of 2, the square of 2 is 4. So what will be sent back? 4. And 4 is an integer. So let's do a square function that will send integers back to us. So let's call this function square. And how many parameters do this function need? So what do this function needs to receive from the main program, or where it was called, to actually be able to calculate the square of a number? It needs one variable or one number, and thus we are going to need one integer. Okay, so that's our function prototype. Then after our function prototype, we start with our main program. Int main void. Okay, and return 0 to show that the program ended successfully. So this is now our main program. Just going to draw a line, and this part comes now after the main. So now we can actually start creating our function. Now the function prototype is just like a name of the complete function, just to show the main function that this function do exist. Now that function will be after the main, so the main just needs to be informed that this function exists so that it knows it can call it anytime it wants to. So now the function will be after the main, and that function also starts with int square and its parameters int a. Then we start with curly brackets, and we also close the function with curly brackets. Now how do we get the square of a value? Okay, so let's say this function receives a value inside this parameter, so the value is now inside a. Now we need to go and calculate the square. So let's say we create another integer inside this function and we call it sum. Oh, not sum, sorry. We call it answer. Okay, sorry, sum. Answer. Now we want to get the answer of the square of this value. And how do we do that? We say answer is equal to a, because the value is now inside a, times a. So now we know that the answer of the square of this value is inside this variable called ans. And now this function has successfully calculated the square of the number. But this function needs to send that answer back to the main program. And how does the function do it? By using the return type. And we can just say return answer. Just returns answer. So this function will return answer, or the square value of a, back to our main program. Now let's say we want to call now this function from our main program. How would we do that? Let's say we have an integer, and this integer we call number, and it's equal to 2. So num is equal to 2, and we want to go and calculate the square of num. All that we need to do is we can just say we create another variable and we call it answer, and answer is equal to the function, and we call that function square, and what we send back or send to that function, we send the value of num. Sorry, that's a very bad num. Semicolon. So what's happening now is we say this answer is equal to the function with parameters num, and this function, this whole thing, will send back the answer to us. Now what I want to quickly just say is, please note that this answer and this answer is not the same. Okay, so let's just make this one red, this one red. This answer and this answer are not the same variables, because this one is inside main and this one is inside square. So it can have the same name, but it's in different functions. This is our main function, this is the square function that we have created. So after we have the value of our function, all that we need to do is print it out to the user. So we can just say printf %d, and we can say answer semicolon. So just to quickly recap, we have our hash include, we have our int square int a, this is our function prototype. Then we have our main function, or our main program, if you want to call it like that. It starts with int main void. We have created int num, that's equal to 2. We have created a variable called int ans. And then we say ans, or for short for answer, is equal to the function with the value num. So num is now equal to 2. Num, the value of 2, is sent to A, our parameter in our function. And now we can work with A. Then we say int ons, and then ons is equal to A times A. So it's effectively A times A, and that will give us 4. And then what we do is we return answer, and answer is 4. And then effectively this value is sent to answer. So answer is equal to 4. Then all we need to do is print it out to the user and end the program. So that's the basics of functions and how we would use functions. Just another thing, we can have different types of functions. Let's say, for instance, we have a function to display something. Let's say display 2 variables. Now note, if we want to go and display something to the screen, and we need a function for that, that function doesn't have to return something to us, and thus we use void. Void is actually nothing. It just say actually in C programming terms that there's nothing, no return type. So void says nothing. And if we want to go and display something, let's say 2 variables, we have 2 parameters. Let's say, for instance, we have a function that returns a float, and this function will give us the value of pi. Now the value of pi is a static number. We don't have to determine the value of pi by using some input. We know what's the value of pi, so we don't need parameters. So we don't have to put anything inside the brackets. Or what we can do is we can put a void. So this will indicate that there's no parameters, but this function will send something back. And let's say, for instance, again with a display function, let's say we have a function void display text, but this function doesn't receive any input, and it doesn't have to send anything back to where it was called. So we can just say void again. So this function has no return type, no parameters, it's just going to display text to the screen. So note that you can have different and multiple options of how this function will work. We have functions that will return nothing back to where it was called. We have functions that will return something back to where it was called. We have functions that will return nothing and also don't receive anything. And then another case, we can also have functions like the square function that we've just done that can send something back and also receive something. So it will send back an integer, but it will also receive an integer. So that's your multiple and different ways of using and implementing a function. It depends on how you want to use this function capability in your program to make your program much more readable and also much more effective. Functions help us to make everything simpler and more easier to do. I just want to show you one thing again. In chapter 2, we've learned about the printf statement. Let's say printf hello. Lo and behold, this is a function. It's a printf function. That's the name and that's the parameters. So we are constantly using functions. You didn't know you were using functions up to this point, but most of your functionality in the C programming language, like the printf, like the scanf, is functions. Where is this functions? This functions is inside SFD201T library. Now let's say, for instance, there's different functionality in different libraries, and we want to include a library that's more mathematical. And thank you very much to all the programmers back in the day that created those libraries. And that library do exist, and we call it the math.h library. So all you need to do is, you need to go after when you include your stdio.h library, you just say #include math.h. And now you have multiple functionality in a mathematical sense. And there's quite a few functions that's inside this library that we can use. Like, let's quickly take one example. There's a square root function that receives one parameter and will determine the square root of a number. There's also other functions such as the exponential function. There's logarithmic functions that will determine the logarithmic value of x, and so forth and so forth. So it's quite useful to use this library inside our main program, because we don't want to reinvent everything from scratch again and again. We just want to go and use what's already been invented inside our new program. So thank you very much for this lecture. I hope you will watch it and understand it. If you are struggling, please re-watch the video again and again until you understand it completely. Go and look at chapter 5 through each of the examples, and then you will understand what functions is or functions are, and you will be able to implement it. Thank you very much.